Hello, we are now ready for solving trigonometric equations. We've been working toward this for much of the year, and we'll just, before we begin, spend a few minutes talking about the prerequisites for this section. All trig equations will get to a point where you either have what we call familiar values, sine theta equals all of these types of values that you remember from the unit circle. 1 over square root of 2, you may not see square root of 2 over 2. You may actually see 1 over square root of 2, but remember they're the same thing. Or you'll have maybe a sine equals a half, or a cosine equals a half, and square root of 3 over 2, square root of 3, 1 over square root of 3, or the quadrantal angles 1, 0, and negative 1. So the very end of a trig equation, you will either have one of these familiar values, or there are times when you'll have decimal values. We'll learn how to take care of those also. So when you see one of these, you have to know right away, if it's 1 over square root of 2, you have to know the reference angle is pi over 4. So that's what you want to be sure you're very familiar with those. Recognize when they are familiar. They're going to be from these 45-degree triangles or 30, 60, 90 right triangles, and all those values will seem familiar. And then you need to know the quadrant 1 values, and then whether they're positive or negative, you will have to find the values in the correct quadrant. So if you would, for example, if you had a cosine equals negative a half, then you would know that the reference angle is pi over 3, but then in quadrants 2 and 3, it would be 2 pi over 3 and 4 pi over 3. So that's something you want to review. Notice the tan, when a tan equals 1, you're not on the quadrantal angles, which when I say quadrantal, I mean the 0, pi over 2, pi, 3 pi over 2, 2 pi. You're not on the axes. You actually are at 45 degrees when you have a tan equals 1. But all these others are going to be values that are on the axes. And you might also include undefined. You should be able to figure out when y over x is undefined. That would mean the x equals 0, and you should be able to figure out what that is. Then, of course, you have to know, now I'm just going to kind of go through some hints here to help you with these. If you have not memorized these for yourself, if you're looking at all the pi over 6 angles, for example, quadrant 1, of course, is the reference angle. Quadrant 2 is just under pi. 5, 6 is just under pi. Quadrant 3 is just over pi. 7, 6 is just pi over 6 beyond pi. And then quadrant 4 is always the hardest to remember, but if you know them all, you can just say to yourself 1, 5, 7, 11, and that helps you remember quadrant 4. And the 45-degree angles, of course, you have your reference angle pi over 4. Quadrant 2, you're just, remember quadrant 2 is here, so you're just a little bit less than pi, so 3 over 4. 5 over 4 is just over pi, and then you have 1, 3, 5, 7. That gives you quadrant 4 as a 7. And the pi over 3 angles, once again, 2 over 3 is just less than pi. 4 over 3 is just greater than pi in quadrant 3. And then those 60-degree angles are 1, 2, 3, 4, 5. 3 pi over 3 being pi. Then I know you know this a smart trig class that will help you with the positive and negative signs. So hopefully you filled all this in and you're remembering the positive and negative signs, because you will use your reference angles, which, remember, the reference angle is the angle with the x-axis only. It's how far you're back from the x-axis or into quadrant 3 from the x-axis. You're always comparing to the x-axis, which is pi or 2 pi, and we'll go over that when we get to that problem. Consider the domain. Domain is your friend, because if you have cosine of theta equals 4/3, that's greater than 1, you know on the unit circle, unit means 1. You can't ever be greater than 1. So right away you say, can't do it. Domain error. You don't even have to say domain error. You just say, just cross it off. There's no answer there. And once again, the Pythagorean identities. You should remember well the sine squared plus cosine squared equals 1. Remember the two forms, and then also be able to note the other two identities. And just a few words about the algebra that you need. Often students wonder why they don't do as well on this test, and it's because it's so cumulative. So expect to have to work harder in this area because you're bringing back everything that you have learned before. GCF factoring is huge. It's going to help you out of a lot of rough spots. We have a lot of quadratic factoring. Whenever possible, if you can get into one variable, now one variable could be sine x, it could be sine squared x. As long as there's only one type of term, then you isolate and solve. Sometimes you'll use those Pythagorean identities to get it into one trig function type. And if it's quadratic, like sine squared, cosine squared, don't forget when you square root both sides, you will have plus minus answers. You will like the plus minus answers. I'll tell you why when we get to there. And then remember, that is all if you have one variable. If you have more than one power of a trig function, for example, you have a sine squared and a sine, or if you have maybe sines and cosines in there, you have to set the equation to 0 and use the zero product rule. That's the only way you can do these. Please don't divide out your variable. You might think, I can just divide a sine out and it'll look a lot simpler from both sides, but then you're going to miss some solutions. So that's just a quick review of what you're going to need to know, and you should come back. This doesn't make sense to you now because you haven't solved the trig equations yet, but as you go through this section, come back and keep reviewing these things that you should know and remind yourself.